At the heart of the Eaton locker is a beveled gear set, similar to the one in the conventional open differential. There are two pinions located on the cross shaft and two side gears spline to the axle. These gears are precision forged for high impact strength. One of the side gears has cam ramps machined on the back face of the gear. These ramps mate to corresponding ramps on the cam plate part. Also, there are 4 detent protrusions on the cam plate which mate to 4 holes in the side gear. This detent system prevents the cam plate from ramping until a predetermined torque is applied to the gear teeth. After the cam plate has rotated out of the detents, the ramp surface on the cam plate engages the ramp surface on the side gear. As the cam rotates further, the ramps cause the cam plate to move in an axial direction. The ramps are symmetrical, so the same action occurs in both directions of rotation. Behind the cam plate is the active disc pack. Behind the cam plate hub is a wave spring that acts to keep the cam plate in the detent position. Following are more friction discs. Ear guides and snap rings are added to help align the parts in assembly. On the other end of the differential, behind the opposite side gear, is another set of friction discs. The disc pack develops torque from the force created by the cam gear that is transferred through the reaction block at the center of the differential and into the disc pack through the side gear. The device that activates the cam plate is the engagement mechanism. It is connected to the cam plate by a small shaft that is geared to the cam plate. The mechanism is attached to the shaft through comb clutches and each end plate. The mechanism can rotate relative to the shaft when the torque between the shaft and the mechanism is greater than the comb clutch torque. The mechanism is made up of 2 flyweights that are spring-loaded toward the center of the shaft. The shaft rotates whenever there is a differential speed between the wheels. When the differential speed reaches 100 RPMs, there's enough centrifugal force on the flyweights to overcome the centering spring. The flyweights move outward to catch the pawl of the lockout mechanism. One flyweight engages the pawl in one direction of rotation, and one flyweight engages in the opposite direction. If the vehicle is traveling over 20 miles per hour, the centrifugal force acting on the counterweight of the lockout mechanism will cause the engagement pawls to rotate away from the engagement mechanism. When this happens, the differential cannot lock up at high speed. With the parts back together, it can be seen how the parts work to cause lockup. With one wheel spinning, the cam side gear rotates relative to the case. This causes the engagement mechanism to rotate at a higher speed. At a given speed, the flyweights will swing out and engage the pawl on the lockout mechanism. This action creates a force to be exerted on the cam plate that causes it to rotate out of the detent position and into the ramping position. The active friction disc engages, which causes the cam to self-energize until enough torque is developed between the wheels to lock them together. With the wheels locked together, maximum driveline torque is available to the high traction wheel.